All right, so in the last webinar, we got a good start talking about how to set up a continuous integration process with TeamCity in the Getting Started with TeamCity webinar. And we went through a process. We're going to kind of give an overview here, and then we're going to look at how we can take those same principles that I talked at the beginning of the webinar about, and how we can build upon those to further improve how we develop our software. And so in the last webinar, we kind of started out looking at uh, we've got versions of our application here, hypothetically maybe versions 1, 2, and 3, and we looked at how we can take a specific version of our application and how we can compile it, make sure that things compile and the compilation process isn't broken, how we can unit test it and make sure that our tests are passing, and then how we can package it up at the end. And we kind of referred to all of this as, and created what we referred to as a commit build, because it runs every single time we commit something to the application, every time we make a change. It's a sequential set of steps, basically, to kind of give us a first level of feedback if there's any types of problems in our application. And it works really good to help us kind of find out about things and catch problems and get moving a little bit more quickly with how we develop our software. But what if we wanted to take the results of this commit build that gets done every time our application changes, and what if we wanted to do some more testing of our application? For example, maybe we have a web application and we'd like to do some testing in various different browsers. And we traditionally may have a lot of automated tests for this, or we may have some manual tests, but whatever it is, maybe it's going to take a long time. So it'd really be nice to take those tests, and as soon as we get done making sure that the basics, the things compile and the unit tests run, it'd be nice to automatically kick off more lengthy testing as well. And then what if once those tests are done and we have some more confidence in what we're doing, we'd like to maybe deploy our application to a QA environment so other people can begin manually testing things and kind of doing some exploratory testing. So that's what we're going to kind of talk about today, and we're going to look at what this can enable you to do, and we'll look at how we set these up in TeamCity. These are what are known as, this is what would be known as a build chain in TeamCity. It's where we can take builds which run sequential steps, and we can form more complicated sequences with them, including running things in parallel. One of the reasons we may want to do this, I mean, we could shoehorn all of this stuff into the commit build we started with. We could run the tests after we get done packaging, but it wouldn't be easy to do that in parallel without some extra work. And if anything went wrong along the way, say perhaps just part of the deployment failed, maybe the network dropped or something to the QA environment, we'd have to start the entire process all over again and wait for all the testing to complete. Whereas if all the testing had already completed, perhaps all we need to do is just try to redeploy the application. So if we break things apart, we can actually retry things as well. So with all these kind of secondary needs, or the next things we may want to do, we need to kind of take a look at and understand how we can form dependencies between builds in TeamCity, so we can hook these things together and orchestrate further builds to kick off after our continuous integration process that we discussed in the last webinar has completed. One of the things we're going to need to do that then is we're going to need to take that packaged application, and we're going to need to be able to share it with the build configurations to run tests. So once we get done packaging up, say, version 3 of our application, we'd like to take version 3 of the application and put it through some functional testing, for example. And obviously, we're going to need the application that was built at that time then to test it. And then once we're done testing the application, we'd like to then actually be able to deploy it. So to deploy it, we're going to need to get access to the package as well. And this type of dependency in TeamCity is what's referred to as an artifact dependency. It gives you the ability to basically take the output of a build process, in this case our commit build as part of our continuous integration process, and share it with other build configurations so that you can form these more complex build chains. Now, this might work just fine if things aren't changing very quickly, but as we adopt continuous integration and we begin sharing our work more frequently, perhaps in the time it's taken to even just package the application, or especially when we're running through lengthy functional testing, perhaps versions 4, 5, and 6, or basically perhaps our application has new changes to it. With artifact dependencies alone, when we go to deploy the application, if the testing, for example, had taken a long time, we may have tested version 3 of the application, but then end up deploying version 4 of the application if we're only using an artifact dependency. So while we know that version 3 of the application tested successfully, we don't have that guarantee for version 4, so we don't want that to happen. To deal with that, there's a second type of dependency in TeamCity, and that's what's known as a snapshot dependency. And snapshot dependencies do two things. First of which is what I was just referring to, is that they allow you to ensure that in a build chain, that the same version of your application essentially, or you're working from the same sources of your application in every single build in that build chain. The second thing they do is provide some ordering. So the artifact dependency, both all three of the downstream builds, if you will, are dependent on the first part of our process, which is the commit build. So from that alone, we can't really know what order to run things through. But once we bring snapshot dependencies in, we can say, hey, the test should run or the Chrome and Firefox test in this case should run after the commit build. And then once those are done and both of those are done successfully, then we should do our deployment. So it gives us some ordering as well. All right, so that's kind of just an introduction to these two different types of dependencies. And before I move forward, I'll just pause to see if there are any questions.
Hey, Wes, can you explain a situation where you might only use an artifact dependency?
Yeah, absolutely. So if, for example, let's say you're doing some type of inspection on a code base, and it's a rather expensive inspection, and you're not going to look at the results of that very frequently. In that case, you may just want to grab the latest version of your application on a nightly basis and do a set of inspections. And you don't really need to have done those inspections for every single change to the application. Not necessarily, perhaps you want that, but if you're just using this on a maybe daily or weekly basis to refer back to, it might be a case where an artifact dependency alone would suffice then. All right. So today I've got a set of examples that I'd like to walk through just to kind of help explore what we can do as we move beyond continuous integration. And all of these examples, I've tried to go back to the principles of continuous integration that we discussed at the beginning of the last webinar and just take those same concepts that allowed us to do something really cool with continuous integration and take those same principles and allow us to kind of continue onward with them and do even better stuff down the chain, if you will. So the first principle that I want to talk about is just feedback and failing fast. So as a part of continuous integration, we do that so that we can get information about perhaps our build is broken, perhaps our unit tests aren't passing, perhaps our application doesn't package. So that starts to give us quite a bit of really good information. But as we were just pointing out in the last example when I was explaining build chains, perhaps we have some testing that's going on. And perhaps traditionally, we only have a single person, whether the tests are automated or manual, to run through those. And so it takes a really long time to get through a set of tests in Chrome, Firefox, and IE. And so we either maybe cut back the tests we do in each of those browsers, or in other environments, we may cut back the tests we run every single time our application changes the downstream more lengthy functional tests, or we may just have to wait a really long time to get that feedback. So to continue this idea of getting feedback faster, we can run those tests in parallel and find out much sooner when there's a problem. And not only in parallel, but we can kick those off immediately after a version of our application has passed the commit phase or the commit build. And so there's no delay in then actually spinning up that testing process. So this will help us get feedback a lot faster. And then since we've run the automated tests automatically, we can then, once those complete, we can actually then move on to deploying to a QA environment immediately as well, so that people can start manually testing things out. Perhaps even the customers can get into environments like this and start providing feedback. All of this allows us, by automating this, to make it happen much quicker by doing things in parallel and get to a point where we can even get manual feedback faster as well. So I'm going to walk through setting this up in TeamCity. And since I just did a very general overview of what dependencies are, we're going to use this hypothetical example to kind of illustrate how we can set up those dependencies. Okay, and so today I've organized the different demonstrations into separate projects. And if you aren't familiar with projects in TeamCity, they're kind of just like folders on your hard drive. You can organize files that I like to think of as build configurations inside of those folders. So projects is kind of like a folder structure. I've organized a set of folders for the different demonstrations we'll walk through. And the first one is this parallel testing scenario. So I'm going to open that up. And just like on that slide, we have 5 different builds that are going to be involved in this. There are 5 different sequential processes. We start with the commit build, a lot like the continuous integration build we did in the last webinar. And then we're going to run 3 sets of tests in parallel. And then at the end, we're going to deploy to a QA environment. To kind of help you understand the snapshot dependency setup a little bit better, I've already pre-configured the dependency between step 1 and all of step 2. And by the way, I like to number these steps as we get into more complex build chains. That's a personal preference, but I like to number them so even when I'm looking at just a list of the builds, they're in order, and I can also mentally understand what order things flow through. So anyways, I'm going to go over to the project settings. Since all of these builds are in the same project, we can hop over and look at their configuration. And since we're doing testing with just basically a different browser each time, I've set up actually a test template. And this is a good feature to use, especially as you get into partitioning your tests, whether you're running a subset of tests and then trying to run subsets in parallel, or you're maybe running on different operating systems, or in this case, you're running in different browsers. Oftentimes, there's just 1 or 2 parameters that vary, and so it's nice to use a build configuration template so that you don't duplicate that configuration. So I have this test template, and you can see it says it's used in 3 configurations. So then the various configurations, Chrome tests, Firefox, and IE tests are all instances of that template. And the nice thing about that then is since these all have the same dependency, if I hop back, this is the part we're looking at right now. These all have the same dependency, so we can use the template and inherit the dependency by setting up in one place, and all the instances of the tests will then reuse those dependencies. So we're going to drill in there, and I'm going to go to the dependencies for this project. And from here, we can kind of explain what I've set up. So I said there's 2 types of dependencies. There are snapshot and artifact dependencies. And the snapshot dependencies are great for ordering things and making sure we're running from the same set of sources or the same version of our application, the same commit or check-in or whatever version control system you're using. The first thing I had to do then was set up a snapshot dependency. And this is the test template. It's part of the definition of all of those second-level test builds. It depends on the first commit build. So that's the dependency. And it depends on that build being successful. I'll get into some options here in a little bit. So that establishes that first set of arrows in the diagram. So that's what we established right there, those orange arrows with the snapshot dependency. And then I obviously need to test something. I want to grab the compiled version of the application. So I set up an artifact dependency as well. And of course, the artifacts were generated as part of our continuous integration process. So I need to, again, have an artifact dependency that points at the commit build as well, step 1. And in this case, the artifacts are in this app folder. So I'm just saying, hey, grab the app folder artifacts and copy them over into an app folder as well. And then there's this little text below that says build from the same chain. And that means that when this build kicks off, it's going to be using the same version of the application. And this is because we set up snapshot dependencies that we get this option for the artifact dependencies. In this case, it's going to grab if we step 1 was version 3 of the application, then we're going to get the artifacts for version 3 and not version 4, for example. So we're testing the same set of the same version of our application, which is a good thing. So that's basically setting up the first set of dependencies. Now the next thing we want to do then is set up, once all of these tests complete, it would be nice to then deploy that to an environment so people can begin manually poking at it. And that's the dependencies I've left for us to go through today. To do that, I'm going to hop back to the project that I've got all these builds in. And it's a nice idea to at least have one project for a build chain to kind of isolate it from other things. Now, as your build chain maybe gets more advanced or whatever your application is set up, you may want to partition that project a little bit with sub-projects. But it's at least nice to keep the parts of a build chain in their own project just so they're not mixed in with other builds for other applications. Okay, so we want to hop to the deploy to QA because we've already seen how the first four are wired together. Now we want to wire up the deploy to QA to kick off after all of the tests have completed successfully. So I can drill into that, and I can go to the dependencies for it. And I can say, hey, we need to add a new snapshot dependency. And this time, I'm going to go to the project we have here, and I'm going to say this one is dependent on all of the step twos completing. So all of the tests completing before this build is going to run. And then I have some options here at the bottom, and probably the most important one to point out is perhaps even if some of the testing failed, perhaps you would still like to deploy the application to a QA environment. You may just use the test to go back and start working on something, but you'd like maybe the default isn't in this QA environment. It's not that important for all the tests to have passed. And if that's the case, then you can run this build even if a dependency has failed. But I'm going to leave that off, and you probably normally wouldn't turn that on. But there may be a situation where you would like to just deploy anyways, and so there's that option. And I'm going to save that. So that set up the other set of arrows in our application. That just set up when the Chrome, Firefox, and IE tests complete, we'll kick off our deploy to a QA environment. And of course, if I want to deploy the application, I also need an artifact dependency as well to grab the artifacts. And so I can add a new artifact dependency. And again, I want to drop down here. I want to go to my project where all my builds are. I'm dependent on, again, going back to the continuous integration output. And I don't want the last successful build. I want to do the build from the same chain. And so it's really cool here is even though this build doesn't depend on the first build, because the builds it depends on depend on the first build. So hopping back here to our diagram, deploy to QA doesn't depend directly on the commit build, but it needs artifacts from it. Because of the dependencies in the snapshot, because of the snapshot dependencies we've set up, the chain here, it can access, not only can it access that, the output of that continuous integration process, it can also be a part of the chain as well, so that not only have we tested version 3 of the application, we're also going to deploy version 3 of the application as well, and not version 4 or 5. And again, I'm just going to grab the app folder and copy it locally, basically, and then I can save that. And so that establishes me going and grabbing the artifacts. So we've got the artifacts and the ordering set up, and we're forming a build chain that's using all of the same version of the application throughout now. That's all we really have to do to set up that process. And then let's take a little bit of a look at what this looks like back in our project. And I've done this I've obviously set this demonstration up in advance, so there are some build chains we can already look at. If not, and this were the first time you had just set up a build chain, you could run the build chain, and over in the build chain tab, you'd be able to see it. That same diagram, though, since I've run this before, and I'll hop back here. So this same diagram here is pretty much what's replicated in TeamCity in the build chains tab. So we have our first continuous integration process commit build, and then subsequent test runs, and then the deployment to a QA environment. And at this point, this has all been run through already, and we'll look at how to trigger this process in the next example. I just wanted to get us a chance to see what it looks like in TeamCity. And you can see the arrows here are forming the dependencies between builds, so it's very easy to understand the build chain or the build pipeline, or a deployment pipeline is another way to refer to this. All right, are there any questions so far?
Hey, Wes.
Yeah.
Just one question. How can you do parallel testing on different operating systems?
So in this example, I've done tests of Chrome, Firefox, and IE hypothetically. When you are setting up the different tests that you're going to run, you can basically parameterize the environment as well. And agents come with a detection of certain aspects of their environment, basically kind of facts about the agent. And you can tie a particular build to a particular operating system then. So if you had perhaps instead of Chrome, Firefox, and IE, you had Windows and Linux, for example, then you could tie those two separate builds to a particular agent that has Windows or Linux on it.
Thanks.
Yeah. All right, so let's move on then. the next principle that was really important part of why we do continuous integration as a practice. I mean, regardless of all the tools we have, if we don't actually share our work more frequently, even if we have a build process, it's not going to give us a lot of information because there's going to be that delay between when we make our change and when we actually share it with everybody else. But as we actually adopt the practice of continuous integration and we begin to share our work with each other much more frequently, we start to build team cohesion. And that's we're all working more like a unified whole instead of being on separate islands, if you will. Extending the principle, I think the principles behind getting team cohesion, which is a big part of continuous integration, we can move down the chain and we can start, I like to think of it integrating further down the chain. So continuous delivery starts to get in this idea of, it's almost like sharing your work by delivering it more frequently. And then the ultimate extreme of this is like continuous deployment, where it's a very fast process to not only deliver the results of new versions of your application into any environment, but to actually deliver it automatically into a production environment with no intervention at all. And as we do all of that, as we move down that line of sharing more frequently, not just with ourselves as a team, I like to think of it as building customer cohesion. Everybody is working together more as one team now. It's not just the developers and the users or the developers and the customers. It's everybody's working more frequently because we're sharing our work with everybody much more frequently. So users and customers and stakeholders can give us feedback much more effectively if they can see the results of that. If they can see the results of that a little bit quicker. And it begins to build this cohesiveness, not just developers and users, but everybody together. And that's really awesome. So for this example, I'm going to walk through a rather lengthy process whereby we will take the continuous integration process and build upon it to kind of like we did in the last one, except I'm not going to do parallel testing. We're going to deploy it to an Azure website in this case. This is like a staging web version of the application. So we've got a staging slot in Azure we'd like to deploy this to. And then we're going to run some tests on it. And then once all that's successful, then we'll actually look at deploying it to the production website in Azure and then running the same set of tests in this case, or in reality, perhaps you have a different set of tests in production. So we're going to look at orchestrating those 5 steps and actually see that happen. So I'm going to hop over here, and just to prove that these websites are not actually working already, you can see the default Azure website comes up, and let me grab the other link here. So here's the staging site, and I'll put that one before the production site. So for this project, or for this principle, I've organized a separate project called Customer Cohesion here. Again, I'm putting all my builds for this build chain separate of the rest. And my naming is rather lengthy here, so I'm probably going to stick with this linear view of the builds. Let's just collapse these so we can see what that looks like. So there's 5 steps to this process. We're going to build on our continuous integration, deploy to a staging environment, and that's this Azure site. Then we're going to run page speed tests on this, and I'll explain why in a minute. And then we're going to deploy to production, which is this other version of the site, and we're going to run the same set of tests there. So as we start deploying automatically to a staging environment, we're pushing continuous delivery. As we automate everything to deploy to production, we get into that continuous deployment. And naturally, then we are going to be giving our users what they're asking for, essentially much more quicker. And of all of the processes automated, so we don't have to really worry about it. We can just focus on making the changes we need to make to our software. Okay, so let's just kind of run through what this looks like. So the commit phase is, again, just our continuous integration process. Steps 2 and 3 get us more towards that idea of continuous delivery because we can actually deploy it into a staging environment in this example. So I'm going to actually run that just so we can see it actually, see the site get updated. So, and I haven't set up any triggering for this. We can discuss triggering if people have particular questions, but while that is running, there's kind of 2 ways you would come about triggering. Sometimes there's this idea that we would like to start with the first build and push through the rest, and that's usually not how triggering works in build chains. Usually what you'll want to do is what I just did. I ran step 2 of the process, which needed step 1 because there's a dependency there. So it went ahead and made sure that step 1 had run, and then it ran step 2. And let's just make sure that that works, and it works. So we've deployed our application. I'm just using an example of Google's new web starter kit here and deploying that out, which involves a build process. Even if you're doing front end type work, there's image optimization. I think in this case they're using Sass, so there's translations to CSS, there's minification going on. So even on front end work, there can be a rather lengthy build process that generates some artifact, and that's what is set up here. And you can even see if you expand the artifacts here, here's the site that we're deploying. So even with just static assets, there can be a build process for that, and you can set that up in TeamCity as well. And then this deploy to staging process, and I can open it up here, go to the configuration for it. It has dependencies to that first phase finishing, and it grabs everything and sticks it in this distribution folder that it then uses an FTP deployer, which is part of the it's part of the set of plugins you can get and add to TeamCity is a deployer plugin. And you can then do various things, for example, like deploy to an FTP site, in this case, an Azure FTP site. So it's a very simple deployment process. And let's hop back to our project and go to the project home. Oh, actually, I can just close this. So the next part of the process is we might actually like to run some tests. And I actually haven't updated the application, so it's still doing some old testing here, but we'll update it in a minute here as well. I can kick off those tests then, and it will take the results of the deploy to staging, what it deployed to staging, and it will actually run a set of tests on it. In this case, I'm using the page speed tests that come as part of the web starter kit. They just give you essentially your page speed score per Google, which is kind of an indicator of how awesome your site is or not. And once that's completed, then you can go in and we can actually like go to the test tab, and we can even pull up into the build log and see the output of running the page speed tests as well. And I've gone one step further then, and this is where you can take continuous integration a little further. I've added, as a part of the process, I have the page score test set up actually emits a page speed build statistic, and that grabs the value that Google returned. And then we can take that statistic and hop back, and we can look at, in our stage 3 page speed, we can actually look at that statistic over time then. So you can set up custom statistics, and you can see here's the page speed. Now, I haven't changed the application to the detriment of the page speed, so it's been the same every time I've run it. But the really cool thing is then you could see a drop in your page speed while you're testing in a QA environment or a staging environment in this case, and you can get some feedback about that. Actually, to the point where we could even hop over to the settings for this page speed part of the process. Remember, this is a sequential build chain, and so we can stop the process if something goes wrong. And we can actually go to the build features, or sorry, failure conditions, and we could actually add a failure condition as well. Then on a metric changed, the page speed score, if it maybe drops below, I don't know, 95, we could actually stop the process right there. So if we had an automated deployment process all the way through to production, we can still stop things from happening that shouldn't. In this case, if our page speed score drops below an unacceptable threshold, for example. So that's why it's really awesome to use TeamCity to orchestrate your deployment process as well, because you can run these very valuable tests, whatever they may be. You know, this is a page speed. Other people have functional tests. People perhaps have performance or load testing. And you can gather all those results back, and you can actually plug them into the deployment pipeline then as a way to shut things down if there's a problem. All right, so let's hop back to the project home here, and let's finish this process out. The main site still doesn't work. And so I can go ahead and say, hey, run everything else through to the let's actually look at this a different way. And my naming's really long here, so you can see. Here's that same build chain view we had before. 1, 2, and 3 have passed, and you can see in this build chain view that 4 and 5 have not been triggered yet. So I can actually trigger things from this nice graphical representation of what's going on as well. So I can run this, and then that will complete deploying things. And I can let us watch that happen. You can even see right from within the build chain, you can visualize where it's running in the process. While that's running, do we have any questions?
Hi, Wes. Yeah, a question from the audience. Can you please explain how to define and use custom metrics?
Yeah, so it's actually stuff I kind of set up in advance. There are different configuration files that are part of the TeamCity configuration, and you basically can go in and it's just XML. You make some modifications at the appropriate place, whether it's a build level or a project level, and you just say, hey, this is the metric I'm going to be emitting. And I was just using a couple, actually there's a rather couple of different moving parts there. I showed you the one part, which was, let's open that up. Whatever your build tool is needs to generate some output for TeamCity to detect the statistic. So over in the config, let's go over the tests and look at that again. I kind of showed that in the build log output. So you can see as part of the page score, in this case, it's using Gulp as a build tool. Part of that task then is to generate the page speed, and then it takes it and it emits this message that TeamCity will pick up then. So TeamCity picks up the page speed from this output, essentially from your build tool. Whatever your build tool is, if it can output stuff like this, and there's a whole page describing this in the documentation for TeamCity, that's the first step. The second step then is to say that you want to add a custom chart. So I added a chart to that part 3 of the process. Oh, and it's completed here, so we can look at that in a minute. But I've added a chart to the stage 3 page speed test, sorry. And so that makes it show up in the statistics then that I can plot page speed. In this case, I'm doing mobile page speed. I could actually have done desktop as well, and then I could plot 2 different statistics on this chart then. And so the last piece, and I can even, it's just XML. The last piece, and there's good documentation on it, the last piece is actually saying this is a build metric, and that goes into the TeamCity configuration as well, so that when I go over to the failure conditions for a particular build, then it will show up in this list as well when we go to failed on a build metric changed. Otherwise, it's not going to be in here until you add it there. So when you're setting that XML up, you just describe what the message should be here and which statistic it refers back to. And if you'd like to see that, just ping Carolyn again. I'll show that it's just XML files, but otherwise I'll move on. So, okay.
Okay, yeah. There was just one more question. What
Sure.
about rolling back a deployment?
Yeah, absolutely. I actually need to do, we'll change the application in a minute here, and I'll add rolling back to my list. And Carolyn, if I forget that, remind me once I get done with, we're going to change the application and see that flow through as well. So I refreshed the prod site here, that deployment is done as well. So we can see that then. If we go over to our application and grab that, and we make a change and we just say change. Let's not put that in a title. Let's put somewhere where you will see that. Yeah, here we go. Let's put it here. Change. Okay. So we change our application and we pull up and we go ahead and we say change header to include change. And we stage that and we commit that then. And I don't have any triggering set up automatically, but you would obviously have some level of triggering set up to kick this off. So to see that, let's go to the project homepage. And shortly here, you should see it say pending. I don't have the polling threshold set up very frequently, so that will come up. There we go. So it's detected a change in our version control system, and it's ready to rebuild a new version of our application. We're on 17, it will build 18. So let's just go ahead and push. Let's kick that off to run through step 3 of the build chain. So you can see it's queued up 3 different builds as part of the build chain. And if we would like, we can click into one of those and actually see what's going on. And this is just a different way to visualize the dependencies that are running in addition to the build chain. I think that this is a little better representation of what's going on. So it's in the middle of compiling things. and then it will kick off the deployment process thereafter. Perhaps that's, oh, it's already running the deployment, cool. Yeah, I'm impatient. And so that's deploying our application to the Azure site, and give it a minute here to finish. Okay, and that should be running the page speed test. So you can see changes showing up. This is the staging version, the staging slot of our Azure website. Here's the production version. It does not have the change yet. And our page speed tests are complete. We could look at the results of that. And again, I can then kick off even from right here the rest of the process to run. I could have just run all of it by kicking off step 5 as well. Now, that's kind of what I like to refer to as pull-based triggering. It's where you set your trigger up at the end of the build chain, this last step you want automated. So if you just want to have deploying to staging and essentially do kind of continuous delivery, then you would probably trigger every change of your application to kick off this page speed test and staging, because then that will actually make sure that it builds, deploys, and tests and staging. If you'd like to be doing more of the continuous deployment world, then you would set up your trigger on the last step 5 of this process, so it would do everything upstream. The other way you can set up is you can go individually build by build and set up a build trigger to on a successful upstream build to kick it off, but it's usually better to just do it downstream and let TeamCity figure out what needs to be built from the upstream then. Okay, so I think that's done. Yay, our production site is updated as well. So that's how we can get a change through our application. Now, we mentioned that we would like to roll things back. So I can come down here to the build chains, and we've got this old build 15. Actually, let's go to build 17. I don't know what I changed where. So let's go to this step 1 commit. Let's say we want version 17 of our application to go out instead. So I can actually come in here, and I can actually then promote this through to deploy to staging, or I could actually promote it through to the staging page speed tests, so that we can actually run the tests as well. So I can take version 17 of the application and redeploy it basically. Mess something up. Let's go back. I may have just screwed that up. Let's do this. Let's go to 18. Yeah, let's go to, commit, and let's go to our history, 17 again. Actually, let's promote this just to the deploy to staging. I think I jumped a little too far ahead there. So, okay, we're uploading to our staging site there. And it's now back to, oh, and this is actually my change from last night, sorry. So this actually has Wes in the title. We could actually go further back and get it without that. So yeah, that's how you can roll back your application essentially, is you just go to whatever version you would like and you can kind of push it downstream. I guess the other way then is, you could always roll back inside of your application code as well and push it that way too as a whole new set of changes, but you can actually come into your history and push the old version out. Cool. Any other questions? All right. The rest of these I won't get so complicated on and so detailed on. I just kind of want to hit on some other, I think, important principles that we can extend to move beyond continuous integration. And the next one is, I like this one a lot. It's about being confident in what we do. And if anybody's been kind of listening into the whole TDD is dead discussion, I think confidence has been talked about a lot, and that's one of the important things about deciding when we apply certain practices and when we don't. And when we can apply a practice and become more confident, not maybe like unrealistically so, but actually confident in a working process, really cool things can happen. And so the example I want to walk through here is I have a NuGet package for just a little open source project I work on. And traditionally, if I'm working on this NuGet package and I would like to release a version of it, I have to make the changes to this project, and then I actually have to make sure things are tested, and then I have to actually deploy the package. So it's a prime example of where we can bring in continuous integration to create the package, in this case a NuGet package. It could also be like a Ruby gem or a package in NPM or a package in any tool you're using. And so continuous integration helps us compile, test, unit test, and package up, in this case, a NuGet package. We can move beyond then and add more confidence to what we're doing by running integration tests. In this example, I have a provider for the new ASP.NET Identity Framework, and it's for MongoDB. So I actually want to run a set of integration tests with MongoDB because that's just a better way for me to actually test that the package works. There's not a lot of unit testing I can do, and with it, I don't like to take MongoDB out of the equation. So I can then, every single time I make a new change to the application, not only will the NuGet package get generated, it will also run integration tests against MongoDB, just in case I forgot to run them myself. And then once all of that's done, that's kind of my checkoff, right? So if I have done a good job of thinking about the feature and how it's valuable and implementing it and putting some thoughtful tests into it, not just mocked out unit tests that get picked on as part of the problem with TDD, but actually do integration testing as well, then I'm ready to publish the thing for other people to use. And so I can then wrap up this build chain by actually publishing the package to the official NuGet feed. What this enables me to do and what this can enable us to do is there's not this mental barrier in our heads anymore when somebody asks us to make a change to whether it's our own application or an open source project. We can focus all of our efforts on making the change and thinking about the appropriate level of testing of that change and working with the person to determine that and working with testers to determine that, or whoever it is that's implementing it. That's our focus. Our focus isn't anymore at all on a safe process to deploy those changes. We can just make the changes with the confidence that we have a process that's going to support releasing it for us so that we don't have to do that. And so this is something I actually use. And I've just found that by having this, I'm much more likely to take feedback from somebody and implement it because, like I said, I don't have to worry about anything after the change has been implemented. The process takes over from there. So I'm going to close those. And got a little different environment here. I have this ASP.NET Identity Mongo project. Again, organizing my build chains together. I start with the commit build that we looked at. There's the integration test build, and then I publish the package. And I don't have any changes to release and don't want to release a new version of the application for no reason, so I won't run this, but I just kind of want to walk through a few of the features that enable this to be possible within TeamCity. So one of the first features, and this was in some of the last examples I had as well, I just didn't point it out, was the build numbering. So in the commit stage, we only want to run and generate our application or build our application and package it once. And then we want to reuse that all the way throughout the process, just so if for whatever reason in the packaging process something changes, if we rerun it again, we don't introduce any types of defects in the process. We've built this version of our application. We've already unit tested it, so we don't want to have to do all that again in a subsequent step. So then an important part of that is whatever version of application we've built, it would be nice to tie a meaningful number to it. And so at this point, this is on a 1.0 release of this package, and then every time a new version of it gets generated, we update our build counter and add that as well. So we form a number for this NuGet package, a versioning scheme off of incrementing the build counter and forming this more meaningful build number than within TeamCity. So TeamCity originates my build numbers, and that's a really great thing we can do with TeamCity then, so we're not doing that by hand and trying to keep track of that somehow. So then you can see that 1.0.10 is the current release of this, and if we look at the history, I have that over here, you can see 09, 08, 07, etc. So we can actually see the various versions, and here's where I actually started using the numbering from TeamCity. So we actually can keep a history of that then, so that's fantastic. And then the nice thing about build chains are we can actually pull configuration parameters from upstream builds just by the fact that we've chained these things together. So in the integration tests, when I go in to edit the configuration settings, and under the build number format versus the, let's look at the commit one again. So I'm going to open these two up. So this one is just using its own build counter. This one, however, has got all this gobbledygook, but basically what this is pulling an upstream from that ASP.NET Identity Mongo project, the commit build. That's how that naming was formed, and it's pulling the build number. So this pulls the build number off of the commit build that triggered this build. So because we're using the same version in every step, we can then reuse our build numbering across the builds as well. So then that's where, oops, sorry, close that. That's where then you can see 1.0.10 here. And then I just like to tack on the end the actual build counter for the integration test, because you can actually rerun the integration test at any point if you wanted to just make sure that they work. You can come in here and re-trigger them basically, and then you'll get assigned a new build number. So even though I don't have a new version of the application, I can see that here in the history. We can even kick off one. You can see I've run the integration test twice on version 1010 of the application, and I'm running it again. So I like to tack the build counter on. Each build has its own counter. I like to tack that on the end just so I know which run it was. And then I also share that through to publishing it. And by sharing that all the way throughout the process, then I can, in my mind, understand what's going on just from looking at TeamCity. But also, there's a few more features that enable me to actually then use that number as part of the NuGet package itself. This is just the build number in TeamCity. If we look at the commit build while that's running, and I go over to the configuration settings, and let's go to the build steps. And in the NuGet pack step, you can see that I'm pulling, this is step 1. I package the application in step 1, and you can see it's pulling the build number from that step, the 1.0.10, and actually using that as the NuGet package version as well. So that means my NuGet package is aligned then. So when I pull that from the official NuGet repository, off screen, you can see 1.0.10. If I do show all versions, there's 1.0.9 and 1.0.8. So the things are lining up between TeamCity and the package I'm actually sharing. And then if I open the application, or sorry, the package up, the next thing that I like to do is make sure that the assembly itself has the same version too. So that the assembly has version 1.0.10. And to do that, I use a separate build feature, which is this assembly info patcher. So if you're doing .NET development, you can use this. It'll actually modify the assembly info file. If you're in the .NET world, you know what that is. It's basically a point where you inject the assembly, you can inject the assembly version. And again, I can pull the build number since this is part of step 1 of the process. Even if it were a subsequent build, since we're chaining things together, we can always access the same number throughout all of it. And I can then actually not only tie the package and all the builds in TeamCity, but also the assembly. So if for some reason somebody comes to me and say, hey, I've got a problem with this MongoDB provider, and the first thing I can say to them, well, is what version you're using. If they don't know for whatever reason, they've lost that, and all they have is the assembly, they can get the assembly version, and then we can tie that back to an actual build in TeamCity to look at things. Or if they have the NuGet package, we can get the version there and tie it back as well. So as a point of centralization, it's great for generating all of your build numbers for your applications and packages and everything else. Any other questions?
Quick question. Can you access a feed of packages to test the package before it's deployed to the official repository?
Yeah, so as a part of the NuGet features within TeamCity, the commit build, right? Let's actually just hop back to the top level here. Let's go to the home page, it's a little cleaner. So these 3 steps of the process actually generate, or sorry, the first step generates the artifacts, which is the NuGet package. I've got it in here. So because we generated that as an artifact, then TeamCity will make that available as part of its internal NuGet feed. So before any of the rest of this even runs in, we could consume that package if we're consuming that feed. And you can get to that in administration and NuGet settings. And, oh, that's weird. It's not disabled. Huh. Maybe I don't have the actual server enabled. Yeah, I've got NuGet set up, but I don't have the server enabled. You can enable it, and then you can get access to the feed right here. So you can actually consume this then. Should work. Where did I put that? Maybe I closed it. Oh, you know what? I don't have authentication turned on. You'd have to enable authentication as well. And you can either make that just public, or you can have permissions to access it as well. So, but then you could pull packages from it. Yeah, I won't go off on too much of a tangent there. Yep. Okay. Any other questions? All right. Interrupt me if there are. I'll move on. The last principle I want to build on is this idea of being in a working state at all times, knowing that it's not just a it works on my machine type scenario. Now, we already started to address that by making sure that we compile the application, run unit tests, and package it every time with continuous integration. So we actually are probably in a pretty good working state. But as we move down, as we apply these same principles further, knowing we're in a good working state kind of means knowing before we ever release to production that things are just going to work when we release to production. And one of the ways to do that is to actually use an environment that's very close to production. And to get out of the code side of things here, let's jump over to the database side of things. So if we have a staging environment with a database that mirrors pretty closely to production, we are probably going to have confidence that when we release our application, it will work with the database in production as well. However, pulling that off is oftentimes very difficult. Whenever that's manual, I've yet to see that happen, that database and staging get updated more than maybe once a month. It's usually updated when somebody just finally pulls their hair out and goes and does it themselves. Even if it is automated, it's maybe automated on a weekly basis. But TeamCity can help us automate it even further. So as a part of what we set up in TeamCity, as a part of the project we use to build the application, we can put components in as well to do things like sync our production database back to a staging database. And the assumption I have here is that our production database is it's being backed up on some frequency. So we can access those backups then to restore to a production environment. And let's just look at what that looks like. For this example, I'm going to use MongoDB just because it's a little easier to run through all of this, and I can refresh things here just to make sure that everything's okay. So in production, we have this CRM database, and the easiest way to demonstrate this is I've just blown away that CRM database of ours in staging. And then I can hop back to TeamCity. Put it, there we go. Let's close some of these that we don't need anymore. And on the homepage, I have a new project for this. And just have one build here. I'm going to go ahead and kick that off. Now this one, what's unique about it is I'll drill into the settings here. The trigger, this is something I've just set up to run every day at 12 o'clock. So all of this automation we're talking about, sometimes the best automation is just to run something on a daily basis. So now every day at 12 o'clock, we would clone we would take our backup of production and we would restore it into our staging environment for us to be able to test with. And let's hop back and look at that. And there's our CRM database. So it's as simple as that. I mean, I know that's an easy thing to look at and see, but take that to its conclusion. If you had a new version of the database in your testing environments every single day, and maybe not even a new version, perhaps you work in a field where you can't even just copy the production data. There's a scrubbing process involved to be able to remove confidential information, for example. So obviously then your process is a little more complicated than just a restore. You have scrubbing. Well, you can add that as well as either a separate build or part of just the build that does this backup. And perhaps you have migrations to your data as well. I mean, we all have changes to make. Even with MongoDB, sometimes we would like to restructure our documents. Perhaps we have some migrations we'd like to run. So every single night, not only can we grab the latest production data, we can run the latest migrations on it as well to give us confidence that we're in a working state with not only our code, but with our database migrations as well. So it's a really cool thing we can kind of get to. And that is it for what I have pre-canned. I'm just going to open it up at this point for any questions anybody has. silence.
I think luckily everyone's questions have been answered, so it's great.
Oh, fantastic. Yeah, what time is it? Oh, we're pretty close to an hour, so we don't have to run it on any longer. I can ramble. So yeah, the important thing to take away is that, and I want to hop back to that slide, I think, and just this one. There's two types of dependencies in TeamCity. Sometimes it's intimidating. Don't let it intimidate you. One is just an artifact dependency. That's just taking outputs and making them inputs into subsequent builds. The other is a snapshot dependency. And think of it as like taking a snapshot, a picture of the state of your application at a point in time, and knowing that every single build will have that picture to work off of the same one. And then build on the principles we talked about. Feedback, cohesion, working closer with our customers, having confidence in what we do, and making sure we're always in a working state, even as we get closer to production.
Excuse me, there is a question in the.
Oh, okay, go ahead.
About ability to ask for some confirmation before deploying to production.
Yeah. So.
Yeah. Could you please show how it can be configured, how one can configure prompt parameter or password parameter to be asked before triggering a build?
Yeah, there's a ton of ways you could come about that. You know, probably the easiest way to do that is you would like to lock a set of people out of the actual deployment to production builds. And that's just a permission issue that you can set up in TeamCity. You can actually assign users to, probably the most appropriate there is to have a group that can actually deploy, perhaps for a particular project. And those people are the only ones that can actually then kick off the deployment process. And then obviously you wouldn't want any of this to be just fully automated. So at that point in our, let's hop back. At that point in the chain, you would trigger up through step 3 automatically every time a change is checked in. But at that point, you would leave the rest of this to be manually done. So somebody else would, and that person then you'd have to literally just ask somebody. I mean, it'd just be like in reality, you'd have to ask somebody for permission then. And at that case, then they can come and push the button in here. And you could also set them up to be getting notifications when, if you'd like them to be doing that, you know, more often than not for whatever reason, they can get notifications every time a new release is in staging that you would like to have promoted. Otherwise, you know, whatever your process is normally to ask them would be sufficient. So, but yeah, locking permissions is probably the easiest way. You could put a password in the build configuration and check the password and then allow everybody access to it, perhaps if you want people as a backup to be able to get it. But I see that probably more as probably not a long term. Right? That's at least how I would approach it. I don't know if there's any other recommendations. So
I think the question was if it's possible to show how the password parameter can be configured in some configuration.
Oh yeah, so if you wanted, I guess you would probably have to. I actually haven't set up like a built-in feature to do this. Perhaps there's a feature or a perhaps there's a plugin that could do that. But if you wanted to add a parameter and do some special testing with it, you can actually go into wherever you would like that to happen at, for example, deploy to production. Go to the settings and down under the parameters. So you can actually see that there's parameters I've set up there actually for this instance that are a part of, these are like hard-coded parameters, if you will. Looks like, is my screen not being shared anymore?
I just re-shared it with you.
Okay, there you go. Can everybody see that? So you could actually add other parameters as well and leave them unfilled and choose how you would like this, but it'd probably be just a configuration parameter that maybe then you use in some build step to validate that. Perhaps you call out to some, I don't know, authentication service and make sure that that's the correct password or something like that. But I would say permission side of things probably the more appropriate way to go, or at least the easier way.
Oh, I just wanted to add that you can on this dialog you can configure specification, parameter specification, and you can define that parameter should be
A password.
password. And in this case, you can also say in the display parameter, you can say that you need prompt. Yeah. And in this case, once someone starts a build, he will be presented with dialog where will be asked for password parameter, and the build script can check for this password.
Yeah, so let's run back and go through what he was talking about there. Customer cohesion. Did that here, I think. So now I have to type in a password. But again, what you do with that password then you have to figure out what you do with that to make sure that that works. So I want people to be aware then they've got to do some checking then.
Okay. Was that it for that question or? Okay, cool. Okay. So thank you so much again for joining us today. To learn more about TeamCity, you can go to the JetBrains website, jetbrains.com/TeamCity. Please feel free to send feedback on Twitter to Wes's tag, which is G0T4, and at TeamCity. The recording for the session will be available, like I said earlier, in a few days at our YouTube channel, youtube.com/JetBrainsTV. You can follow TeamCity on Twitter, again, at TeamCity, and at our blog. And if your company is in need of an individual demonstration or session, if you think your company might benefit from that, please let us know. Thank you again so much for joining us, and we hope to see you at future webinars soon.